Here's an overview of the three major types of bonds, as well as polar covalent and nonpolar covalent bonds. Consider sodium chloride. Recognize that sodium is a metal and chlorine is a nonmetal, and you should identify this as an ionic bond. In the case of fluorine, both fluorine atoms, while they're identical, they're to the right of the staircase, and so therefore this is a covalent bond. Similarly with iodine, both to the right of the staircase, this is another covalent bond, sharing of electrons. The chlorine to magnesium bonds here, and there's two of them. I don't think there should be a 2 there, by the way. That should be removed. Those are metal to nonmetal bonds. They are both ionic bonds. Carbon dioxide. Well, there's double bonds involved, but that doesn't really matter. Everything's to the right of the staircase, covalent. Sodium to oxygen bond, as shown here, is a metal, left of the staircase, to a nonmetal, right of the staircase, and therefore that is a ionic bond. And finally, if you just have a pile of iron, this is all metals, and so it is simply a metallic bond. One way to check for this is to look if there's a metal present, like here, or here, or here. Now, if it's alone, it'll be a metallic bond, but that's relatively rare. If it is bonded to a nonmetal, and it oftentimes will be, that'll be ionic bond. If there's no metal present, it has to be a covalent bond. Let's take a look at covalent bonds a little bit more deeply. Imagine two identical nonmetals, for example, a carbon-carbon bond. Could we not agree that those electrons must be shared absolutely evenly, since they have the exact same desire for electrons? Since they're shared perfectly like that, we refer to that as a nonpolar covalent bond, meaning that that covalent bond is not polarized. It is not excessively positive or negative. When you take a look at this in organic chemistry, this will be looked at in excruciating detail, since if you're doing a chemical reaction and you'd like to attach something to that, and if what you're adding to the mix is negatively charged, it will attach to whatever tends to be the most positively charged. So a good analysis of this is essential for organic chemistry. For us, this is good enough. A carbon to oxygen bond would be a polar covalent bond. Since oxygen is closer to fluorine on the periodic table, it has a higher desire for electrons. It only needs 2 more, for example, to obtain a full outer shell. And so when you have 2 different nonmetals, that's a polar covalent bond, and those are very common. An exception is the carbon to hydrogen bond. They wouldn't want to call a hydrocarbon a polar covalent substance, and yet that's most of the bonds are carbon to hydrogen bonds, and they're very close in polarity, so we give that an exception. That is a nonpolar covalent bond. Here's an overview of ionic, covalent, metallic, nonpolar covalent, and polar covalent bonds.